Hello! This video is about simultaneous equations. It's not going to teach you how to solve simultaneous equations using algebra. I'm hoping you already know how to do that. This video is about solving some even more complicated simultaneous equations using graphs. Okay, here we go. So let's begin with a pair of simultaneous equations that you would know how to solve anyway using algebra, just to check that the graph method works. So what I'm going to do is, first of all, I'll put those in the format that you're probably used to when plotting graphs. Y equals mx plus c. I've just rearranged them. I've added 2x to both sides in the first equation and 3x to both sides in the second equation. So now what I need to do is plot those two graphs. So presumably you can plot some straight line graphs. And the point we're interested in is where they cross, the intersection of the two graphs. Because at that point, both of them are true for that x and y value. So there is the intersection point. The coordinates of that point are 3 and 10. X is 3 and y is 10. So that's the solution of those simultaneous equations. X is 3 and y equals 10. Okay, let's have another go. Two more equations that you'd know how to solve algebraically. I'll rearrange them into the form y equals mx plus c and then plot them. And it's the intersection that we're interested in. There it is. The coordinates of the intersection are 3, 5. So the solution of those simultaneous equations is x equals 3, y equals 5. Now, the benefit of this method is that it works for some quite complicated equations that might give your algebra a bit of a problem. So let's have a look at these two equations here. The second one is a quadratic. The graph will be a parabola. So if we draw the two graphs, they look like this. And can you see that they actually intersect at 2 points? So for these simultaneous equations, there are two sets of answers. The first one, the coordinates up there is 4, 11. So the solution would be x is 4 and y is 11. But the other point of intersection right there has coordinates -3, 4. So the solution there would be x is -3 and y is 4. So we've solved the simultaneous equations using the graphs. Now what we could do is just check that our solution is correct. If we substitute the x and the y values into the first equation should balance. Let's see, if x is 4 and y is 11, 11 equals 4 plus 7. Yes, that works. But let's check that those same two values work in the second equation. Substitute them in. Y is 11, so 11 is equal to 4 squared minus 5. 4 squared is 16, minus 5 is 11. Yes, it works. The values of 4 and 11 work for both of those equations. Right, now we have an equation with x to the power 3 in it and another equation with x to the power 2 in it. So let's have a look what those graphs look like. Well, I can only see one point of intersection, and this time the coordinates are not whole numbers. So I'm going to give my answer to 3 significant figures. In this case, x is 1.32 and y is 1.27, correct to 3 significant figures. And finally, this is the sort of question that you may get in which you can use this technique. It says use the graph of y equals x cubed minus 2x squared plus 5x minus 4 in order to solve that equation. So perhaps in the exam question that this appeared, you are actually given the graph that's mentioned there. So they've drawn it for you, they've plotted it accurately, And what we need to do is use that to solve the second equation. Well, the equation is not quite the same as the first one. So what I'm going to try and do is make it so that it is the same as the first one. And to do that, I subtract 3x from both sides and add 5 to both sides. So now you can see in blue, that is the equation or the graph that we have been given. And that must be equal to minus 3x plus 5. Well, minus 3x plus 5 can be drawn as a graph, a straight line graph. So basically I need to know where the blue and the red graph intersect in order to solve that equation. First of all, I plot the blue graph, and then I plot the red graph. I'll look at the point of intersection and then estimate the answer to 3 significant figures. So I get x is 1.27, correct to 3 significant figures. Okay, now it's your turn to have a go at the online exercise. Don't forget to press the check button regularly as you're working through the questions to see if you're getting them right. And if you make a mistake, have another think and correct your answer and then press that check button again. Don't forget to claim your trophy when you've got to the end. And there are lots more activities on the Transom website for you to have a go at to improve your mathematics, and you can claim hundreds of trophies. So, what are you waiting for? Get going! Bye!
You can find Transom Mathematics at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.